welcome you all for the BNF demonstration. First of all, let me explain BNF. What is BNF? The BNF is a meta syntax you can use to express the grammar of a formal language. This might make no sense at all, so let's split it up. Baker's-Nuer notation, more commonly known as BNF or Baker's-Nuer form, is a formal mathematical way to describe a language, which was developed by John Baker and possibly Peter Nuer as well to describe the syntax of the Algol 60 programming language. So, what is a syntax? A syntax defines the structure of a sentence. Don't just think about the normal sentence here. An expression in a programming language can be sentence as well. In every language, there's an alphabet. Example, the alphabet of integer number consists 0, 1, 2 up to 9. A syntax defines how characters from this alphabet should be placed together from a valid sentence. Next, we discuss about grammars. What is a grammar of a programming language? Grammar is a set of rules against which sentences can be checked to figure out whether they are valid or not. Do not being valid does not imply the sentence got a real significance. There are some standard meta symbols used in BNF. The meta symbols of BNF are: the double colon with equal sign means is defined as. The vertical line defines the meaning of OR. It's like a OR operation in logic gates. The angle brackets used to surround category names. The angle bracket distinguishes syntax rules names, also called non-terminal symbols, from terminal symbols which are written exactly as they are to be represented. There are two sets in BNF. One is the terminals. A terminal symbol, such as a word or a token, is a standalone structure in a language being defined. Also cannot divide further. Terminals are symbols in the language being defined. Example, while, for, equal sign, square bracket. Other one is non-terminals. A non-terminal symbol represents a synthetic category which defines one or more valid phrasal or sentence structure consist of an n-element subset. Non-terminals are used to talk about the language and are enclosed in angle bracket. Examples, assignment, statement, declaration. That's about it. If this is not very clear to you, never mind. The upcoming examples should be explained a lot. I will explain you through the easiest example of correct grammar that how to write the name. Example, Dr. Y.A.S. Cruz. First, we identify the entire sentence as a full name. We can divide the full name into three parts. They are designation part, initial part and surname part. We can write like that. Actually, surname is a kind of word. A word consists with letters. At the end of the name, there is a full stop. We should mention it. Particular grammar should be like that. So, a string is made with letters. A letter should be A to Z. We can mention it as follows. Initials consist with letters. We can write like that. So, initial should be one letter or more. It should write as recursion. But after every initial there is a full stop. We can mention it as follows. Then, a letter should be in an alphabet. We can write it as follows. Finally, designation of a person may be one of follows. It is represented separately using O symbol. I think you have a little understand about the BNF grammar. Let's discuss the advanced example of BNF to get a further knowledge of BNF grammar. We have to write BNF grammar for below expression, but we should careful about the operator precedence. First, a one variable or set of variables with operators we introduce as expression. One expression is equals to another expression or set of expressions. According to this equation, left side expression A is an assignment. So we call as assignment and it equal to some expression. An expression might be an addition of two expression or subtraction of two expression or maybe a single expression. We can mention it as follows. There are unknown non-terminals, so need to define them. Next, expression 1 is a multiplication of another different expression or single different expression. We call as expression 2. Expression 2 may be another expression inside parenthesis or variable. According to the grammar, the variable should be x, y or z. That's the way of writing grammar for expression. A grammar is a generative device for defining languages. The sentences of the languages are generated through a sequence of application of the rules, beginning with the special non-terminal of the grammar called start symbol. A sentence generation is called a derivation. In a grammar for complete programming language, the start symbol represents a complete program. Rules of derivation. First, the derivation should begin with a start symbol. Second, it should repeat until only terminals remain in a sentence. Third, replace one occurrence of the symbol in a sentence matching the left hand side of a production with the right hand side of that production. But there may be many occurrences of a single production left hand side in sentence. This can sometimes cause problems. We will discuss it under the ambiguity. There may be many possible matching production in left hand side in sentence. This is not a problematical. In general, an infinite number of legal sentences can be produced. Also, there are some preconditions. Every string of symbol in a derivation is a sentential form. A sentence is a sentential form that has only terminal symbols. A leftmost derivation is one in which the leftmost non-terminal in each sentential form is the one that is expanded. A derivation may be neither leftmost or rightmost. Let's try to derive this BNF grammar. With start symbol aside, ID is equals to some expression. Then, according to above grammar, we can directly assign A to ID. Next, we can derive expression further according to the grammar. Expression is equals to subtraction of expression and expression 1. However, we should set the derivation to get a final result without eliminating grammar rules. We can derive this step until get the terminal. Now, we can directly assign variable z. For getting a proper format of the expression, we can further derive expression 1 as follow according to the grammar. Then, expression 1 is substituted to expression 2. Next, to getting correct format, expression 2 is substituted like that. Now, we can directly substitute var into x. Now, there is only non-terminal. We need to derive it until get a terminal. Now, we can directly substitute var into x and y. Now, the expression consists only terminals. If the final result is equal to the right hand side expression, then we can come up with the conclusion that our grammar is correct. Actually, the final result of a derivation is equal to the right hand side of the expression. So we have used correct grammar format.